So today we're going to do a quick little review of scatter plots and trend lines. And nothing that we're talking about today should be new because we did a lot of it last year in your 7th grade pre-AP class. So a scatter plot is just a way to show the relationship between two variables. And if I look anywhere on this page, I remember that it's the graph with all the dots that are scattered all around. Maybe that's why it's called a scatter plot. And we have three types of relationships. We have a positive relationship where all of those dots, the general pattern of those dots, are all going up. We have a negative relationship where they're kind of all going down. And we have none. Those dots are just all over the place. There is no pattern to them whatsoever. And when we have scatter plots, we make lines of best fit. Those lines of best fit are only for positive or negative relationships. I cannot make a line of best fit for a scatter plot that has no relationship. And we use them to make predictions. So we're going to have two different papers. Your first paper is going to be all about, here is a scatter plot, choose the trend line that best fits that data. And then the next paper is going to have, here are some points, write an equation, now make a prediction for it. Just as a reminder, your line of best fit should follow the path of your points. I'm going to skip over that first example problem. I'm not a huge fan of it because it's not counting by ones, and I think that it's trying to be a little too deceptive for an example. So we're going to start out with the problem that says more examples down at the bottom. The first thing I want to do when I'm looking at a scatter plot and trying to choose its line of best fit is I'm going to look at the type of relationship. This scatter plot is a negative relationship. It is going down. So your slope, your number attached to your x, should be negative. So I'm going to get rid of answer choice A, and I'm going to get rid of answer choice B because neither one of those slopes are negative. When I look at B and D, both of them have a y-intercept of -2, which is right here. There's a dot. When I look at B, it's going down 3 over 1, 2, 3, 4, 5. I could go the opposite way, 1, 2, 3, 4, 5. And if I connect those dots, let me connect them. If I connect those dots for answer choice B, y equals -3/5 x minus 2, that line isn't even close to the relationship of those dots. But if I look at that other answer choice, so I'm going to get rid of B because B is not even close. When I look at the other answer choice, I'm going to change colors. That y-intercept is still -2. But this time the slope is -5/3, going down 1, 2, 3, 4, 5, which would actually be off that graph, 1, 2, 3. I'm going to go the opposite direction as well. Instead of going down, I'm going to go up, 1, 2, 3, 4, 5. Instead of going right, I'm going to go left, 1, 2, 3. If I connect those dots, let's change the color of that line. Maybe. If I connect those dots from dot to dot, y equals -5/3 x minus 2, that line is is a much better fit. It is much more representative of that scatter plot. So that would be our line of best fit. I want you to pause the video for a second, and I want you to do problems 2 through 6 on the back. Pay attention. If your slope is negative, then if your slope is going downhill, then get rid of anything that does not have a negative slope. If your line is going up, get rid of anything that might have a negative slope. Pay attention to the direction of your line. Once you've finished problems 2 through 6, go and check them on the answer key that's on the bookshelf, and then continue the video. So we're used to having a table and being able to write an equation for that. I could type it in stat, and you guys have the steps for stat. So I'm going to go ahead and jump through that. Our example, y equals, if I use stat, negative 1.07x plus 92.87. Again, I got that equation from using stat. You guys are pretty familiar with stat. You did great with stat today, so we're going to kind of rush through that. Part B is where I really want to put our focus today, because that's the part that we might not have gotten a ton of practice on last year. We're going to estimate the average temperature for a city with a latitude of 48 degrees. If I look at my chart, my latitude were my x numbers. So we're going to substitute in y equals negative 1.07. Instead of x, I'm going to use this x number, which is 48, plus 92.87. And I'm going to go ahead and do that math, and I'm going to solve it. Y equals 41.51. If I look at my chart, 48 degrees should be somewhere between 40 and 50. So I would expect it to be somewhere between 58 and 43, or at least super close to that. Remember, this is a scatter plot, so it's not a perfectly straight line, but it's going to be pretty darn close. 41.51, I would say, is definitely close to that 43 mark. If I wanted to put a label on it, because we want to do good habits, our Y values are temperature in degrees Fahrenheit. Now that the video is done, or once your video is done, I should say, I want you to complete problems number 2 through 7. If at any point you'd like to check yourself, there's an answer key over on the back bookshelf, or over on the side bookshelf, I should say.